Good morning, and welcome to today's Electronic Design webcast. Our topic today, how security-enabled Wi-Fi solutions can help protect sensitive information, sponsored by Texas Instruments. I'm David Maliniak with Endeavor's Design and Engineering Group. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow help icon below the slides. This webinar technology allows you to resize the presentation by clicking the maximize icon or by dragging the lower right corner to enlarge the window. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next week. You'll be notified by email when the archive is available. Now let's meet today's speaker. Ben Moore is a software applications manager supporting Wi-Fi technology at Texas Instruments. He's been working with TI's embedded processing products since 2013, during which time he has focused on software support for multiple technologies in TI's microcontroller portfolio. You can learn more about our speaker by clicking on the blue speaker bio widget on your console toolbar. Now let me turn things over to our presenter. Ben, the floor is yours.
Awesome. Welcome, everyone, and thank you for joining our session today. Our topic is how security-enabled Wi-Fi solutions can help protect sensitive information. And there will be three main components to the session. First, my presentation. Then second, we'll have some poll questions throughout that we'll appreciate you guys' participation in. It'll help us get some real-time feedback and insights into your security needs for your application. And then lastly, the Q&A session as described earlier. So first, let's get it kicked off with our first poll question. The first question is, what type of information is the most important for you to protect in your application? Is it user information or intellectual property like code that's being used in your system, private keys and identities, things that might be used to authenticate to your network, or all of the above? So I'll give you guys a couple seconds to enter your responses and then press the submit button and we can look at the results. All right, let's see what we got. All of the above, 100%. Okay, that's pretty interesting. It's definitely good to be thinking about all these different assets that you might be wanting to protect in your system, but it's really interesting that everything is kind of top priority for you guys. That leads nicely into our first section of the presentation, where we want to describe a framework for evaluating your security needs. The reason I want to start here is because every good security strategy starts with having a security assessment that can answer three fundamental questions. The first question is the one that we just answered all together, and that is, what in your system are you trying to protect? Are you trying to protect identity and keys? Is it sensitive data like user information or proprietary data? Or is it the code that's actually running on the system? After you answer this question, the second question you need to answer is, where are you trying to protect these assets? Is it during storage when they're at rest in the system? Is it at runtime when these things are at use, being manipulated in main memories? Or is it during transfer when they're being transferred over a physical interface or even a wireless interface that might be included in the system? Then the last question that you need to answer is, what are you really trying to protect against? Is it trying to prevent the asset from being stolen by some malicious entity, or just the asset being controlled by some sort of malicious entity? Once you've answered these three questions, you can typically start to narrow down what are the main security enablers that are important for your product or your system. And what we mean by A security enabler is a category of security feature that a semiconductor device or a TI device may support. Here, when we say security enabler, we're referring to a hardware-based feature. So it's usually a component of the silicon design, but it could also be software that's embedded in the device, like embedded in ROM. So a couple examples, just so you can think a little bit about what this means for devices you've worked with in the past. It could be hardware encryption engines or hardware accelerators. It could also be something like secure storage, or even something like separate execution environments. All of those are features of the silicon that can enable security. And we have a full set of definitions for the security enablers that apply to TI devices, and those can be found online at www.ti.com/security. So I encourage you, after you guys do your assessment, kind of go out and look at the different security enabler categories that TI offers. The last topic that I want to briefly introduce as part of our framework is CVSS scoring, which stands for Common Vulnerability Scoring System. It's a standardized method of assessing security vulnerabilities. And by that, I mean it can help you associate a numerical score with a vulnerability that represents the relative severity of the vulnerability. And the reason this is important is because when you are planning a project where you need to protect multiple assets from a bunch of different threats and with multiple exposure points, you need to set a relative priority of how you're going to implement security in your system. You may not be able to protect against every scenario, and so you need to decide which ones you're going to prioritize and work on first. And this is something that's a tool that can help you do that. The way it works generally is it allows you to break down a vulnerability into different components that characterize it. So it's how the attack is instrumented, how complex the attack is to carry out, whether specific privileges are required by an attacker in order to carry out the attack, whether user interaction with the end system is needed to carry out the attack, and then what does it impact? Does it impact confidentiality of data, integrity, the availability of data or the system? All of those feed into how severe the attack might be. So there's a lot of resources online for learning more about this scoring system. It's something you'll probably see in the industry, and it can help you with evaluating risk. Okay, that concludes our short introduction of a framework you can use for thinking about your security strategy. Now let's talk a little bit about how embedded Wi-Fi devices help enable security. So we'll cover three fundamental features that most Wi-Fi devices include, and then we'll start to talk about three more advanced features that you might find in Wi-Fi solutions. The first topic I want to touch on is cryptographic acceleration. So here I'm showing three different potential architectures for Wi-Fi solutions. In the top left, we have a system that's using a Wi-Fi transceiver, so a device that's only implementing the Wi-Fi protocols, none of the higher level networking protocols or TLS or application protocols. And then at the bottom left, we have a network processor type architecture where you have the Wi-Fi protocols and the internet level protocols all integrated into a single chip. And then on the right, we have a full wireless MCU. And the wireless MCU is integrating the network processor with the actual application's MCU that's running the application. So these are three different architectures for a Wi-Fi solution, but they all incorporate hardware accelerators to improve performance, because cryptographic acceleration is a fundamental building block for security in Wi-Fi. Now let's talk about a specific way cryptographic acceleration can be applied. So one of the most common Wi-Fi security features is Wi-Fi protected access. And what I mean by Wi-Fi protected access is WPA, WPA2, or WPA3 security, all which can help protect data on a local network. So it can help protect data during transfer, as well as help authenticate end devices to an access point. And the way it helps protect data is it provides mechanisms for establishing symmetric encryption, as well as performing integrity checks on the data that's sent within the local network. So this is common. You'll see a lot of Wi-Fi networks in residential and commercial applications using some form of Wi-Fi level security. But when thinking about Wi-Fi products, typically they're not just sending data within a local network, but also to some remote servers. So when we're thinking about how do we protect data outside of the local network, we're typically thinking about transport layer security. And transport layer security is a higher level security protocol that works at the socket level to enable end-to-end protection of data during remote transfer. So this could be if you're generating some sort of data on your system, and then you need to send it to a cloud server or application server for further processing, or it could also be used when you're doing things like trying to send software updates to your end product. TLS can provide mechanisms that help protect that data or information by encrypting it during transfer, adding integrity checks, and all of that applies end-to-end from the device to the server and vice versa. Okay, so that covers the three fundamental security features that I wanted to touch on relating to Wi-Fi devices. Hardware accelerators are common in all different types of Wi-Fi architectures. Wi-Fi security is a fundamental component, and then transport layer security is pretty essential. Now let's talk about some more advanced features. So looking at a Wi-Fi system on a chip type architecture where we have the network processor performing Wi-Fi protocols, internet protocols, and an applications MCU all integrated into one device. One of the security enablers that's important for this type of device is separate execution environments. And by separate execution environments, what we mean is having physically separated processing resources and memory within the device to handle different operations. In this diagram here, we're showing an architecture that would use a physically separate environment for running the application code on the left in red, and then another environment in blue on the right for handling the internet level protocols and the Wi-Fi protocols. So the reason having this kind of partition is important is because it can limit the access to sensitive information within the system at runtime and provide some additional protections at runtime. So you can think of a couple different scenarios where this could be helpful. First off, you can think of, okay, you have your application code running, and you want to make sure that if some sort of attack were to be instrumented on the network processor to cause the network processor functions or the networking stack to crash, you don't want that to interfere with your application code, which may need to continue to operate and service real-time deadlines. On the other hand, you can look at it the other way and think about how the network processor is handling sensitive information like passwords or private keys that are used for securely connecting to your networks. You don't want buggy application code to potentially expose a vulnerability or cause a crash that would expose this information to some sort of attacker. So by physically separating these environments and limiting the access to this information at runtime, you kind of reduce the attack surface and help secure your system. Okay, so that covers runtime, but now let's think about when you have your sensitive information in storage on the device and you want to protect it against an attacker that may have physical access to the system. This is where having secure storage, like a secure file system, can be beneficial. And particularly in this case where you're working with a system on a chip that's directly interfacing to an external memory to enable persistent storage, you want your Wi-Fi device to have an actual embedded mechanism for creating that file system and securing it. So that can come in the form of performing data encryption, so that the secured information stored off chip is stored in an encrypted format that can only be read by the device that stored it. That can be also in the form of integrity checks, where the Wi-Fi device will verify that information on the external storage hasn't been tampered with before it reads that information into memory and then uses it. Or lastly, it could come in the form of signature verifications, which can be used by the Wi-Fi device to make sure when it receives information that it wants to store in a persistent format off chip, that it can check to make sure that information came from a legitimate source that signed the data. So all of these fall into the category of secure storage, and it can be a very important feature when thinking about how do I persistently store passwords, private keys, or things like copies of code that might need to be stored off chip. The last advanced feature that I want to touch on is device identity. What we mean here by device identity is a mechanism that can be used by a Wi-Fi device to uniquely identify itself when it's connecting to another system, such as the cloud. So transport layer security helps ensure that data is protected and encrypted when you're transmitting it from a system to the cloud. And it also incorporates a feature called client authentication that can enable Wi-Fi devices to authenticate with a cloud server when they're establishing a connection. But to be able to do that reliably, what you want to have is you want to have unique identities built into your Wi-Fi devices, so you can make sure that only systems you produce are connecting to your cloud instance. And a good device identity is based on two main components. And there can be a unique device ID, or just generally some unique number that's used by the device to uniquely identify it. But then you also need to have a unique device key pair, or an asymmetric key pair that can be used to perform some sort of signature operation on that identity to prove that the device actually owns that unique ID that it's presenting. Otherwise, it could be easily spoofed by another device that would copy that ID. So that covers the few main security enablers that I wanted to touch on today. There are certainly many more that apply to Wi-Fi devices, but those are some of the most important. If you want to find out some information about more enablers that apply to our devices and Wi-Fi devices in general, please check out www.ti.com/security afterwards. Now let's spend some time talking specifically about TI's Wi-Fi portfolio and the latest Wi-Fi security standards. TI has two Wi-Fi product families, the WiLink product family, which includes Wi-Fi transceivers, as well as Wi-Fi and Bluetooth combo devices. And then we also have the SimpleLink product family, which includes the more integrated Wi-Fi network processors and Wi-Fi MCUs, or SoCs, that integrate the network processor with an application processor. So the wireless MCUs typically include a broader range of security enablers because they are handling the higher level protocols as well as the application code as well. But in general, both product families are designed to enable developers to create secure Wi-Fi solutions based on them. And one of the ways that we're enabling that is through the support of the latest generation of Wi-Fi security, or WPA3. So WPA3, just for a little bit of background, builds upon the success of WPA2 by adding in some new features and removing outdated legacy protocols. One of the specific features that it incorporates that's important is called simultaneous authentication of equals. And this is effectively a more secure protocol that replaces the pre-shared key mechanism of WPA2 for authenticating a device and establishing encryption keys. The other key feature that WPA3 integrates is called protected management frames, which applies protections to Wi-Fi management frames that are sent by devices on a local network. This is not a completely new feature. It was around before, but it was optional with WPA2. What WPA3 is doing is it's mandating the use of this when devices connect to a network using WPA3 security. And that provides some nice benefits against attacks where people might try to forge management frames to force Wi-Fi devices to inappropriately disconnect from a network, or potentially even create some sort of denial of service type scenario. For a full description of all the enhancements with WPA3, though, I recommend you go check out the Wi-Fi Alliance website. Their main security website provides all the details of the WPA3 security protocol. But regarding TI Wi-Fi devices, I want to mention that WPA3 is being supported within both the SimpleLink and WiLink product families. And this is important for two main reasons. First, you want to make sure when you're developing a Wi-Fi based product that your system remains compatible with infrastructure, which will be rolling out updates and potentially enforcing WPA3 level security in the future. But also, as of June of last year, it's worth noting that the Wi-Fi Alliance started mandating WPA3 for all new Wi-Fi certifications. So that means if you're going to develop a product that needs to be Wi-Fi certified, you need to be able to support WPA3 within the product in order to get that certification. And both the SimpleLink and WiLink product families are enabling that today. The second unique feature that I want to talk about in relation to the TI Wi-Fi portfolio is FIPS validation. Specifically, the SimpleLink Wi-Fi and WiLink devices or Wi-Fi product families include devices that are FIPS 140-2 level 1 validated. And what that means is there are specific devices we've taken to be tested by an external accredited lab approved by NIST to verify that the cryptographic modules within the devices have been tested and are performing to the standards defined by NIST. For the SimpleLink devices or the CC3X35 devices that have passed this validation, there are some additional security claims that are reviewed beyond what was done for the WiLink devices because they're incorporating the higher level networking protocols. But overall, the benefit here is that if you are working on developing products that need to work in certain applications, such as in applications being used by the US government or being used in banks, or even in certain cases in medical applications, you may need FIPS 140-2 level 1 validation for your product. And by having a Wi-Fi device that has already been validated, you can save time and money towards getting your overall product validated as well. And if you don't need FIPS validation, there's still the extra inherent benefit of knowing that the TI Wi-Fi devices have been reviewed by an external lab and that they are performing reliably in terms of the cryptographic operations that they're implementing. Now, we've spent a lot of time talking about TI Wi-Fi and Wi-Fi security in general, but I do want to take a second to mention that it's not just with TI's Wi-Fi devices that TI is setting a high priority on security. TI has a long history of developing chips and devices with security enablers, as well as technologies and resources that help designers meet their security requirements related to their systems. And TI realizes that security is an ever-changing landscape. So in an effort to help support developers when they're trying to address their security needs, TI has formed the TI Product Security Incident Response Team, or PSIRT, which oversees a process for accepting and responding to reports of potential security vulnerabilities involving TI semiconductor products. And that can be related to our hardware, software, or even our documentation. So this is a cool initiative being done by TI. We have a dedicated web page at www.ti.com/pcert that describes how this team works and how you can get in contact with them if you want to report a potential security vulnerability. Now that concludes everything I had for this session in terms of presentation today. I'd like to do one more poll question before we jump to the question and answer. When you're thinking about security, what type of applications are you looking to add a secure Wi-Fi solution to in the future? Is it a building automation type application, such as video doorbells, electronic smart locks, thermostats? Is it a medical application like a CPAP machine or multi-parameter patient monitor system, grid infrastructure, appliances like industrial washers and dryers, stoves, things like that, factory automation, or consumer electronics? I'll give you just a couple more seconds to respond to that, and then we'll check out results. Okay. Okay, cool. Look, it looks like we have a good mix of applications here. A lot in factory automation and building automation. We definitely see a lot of activity there, and certainly security is a very high priority. There. Also, some consumer electronics, a little bit less in medical, and I think that kind of makes sense. It is a bit surprising that there's no one focusing on appliances, but maybe there's a little bit of overlap with the building automation space. Thank you guys for that feedback. Okay. With that, I think we can jump to the Q&A session.
Great. Thanks, Ben. Excellent job. And a few of you have already submitted some questions, so we'll jump into those. If you'd like to submit a question now, please type it into the question window on the side of your screen and hit the submit button. While we're answering your questions, please complete the feedback form located on the bottom of the screen. All right, Ben, the first question is about WPA3. Why should anyone care about that, and which TI devices support WPA3?
Okay, good question. So the first reason to care about WPA3 security is that it introduces updates to Wi-Fi security that enable more reliable, more secure connections to access points. So we talked about the one feature, simultaneous authentication of equals, which enables more robust password management. So it enables people to use shorter passwords that provide the same level of security for systems connecting to a network. The other feature is the protected management frames, which it is now enforcing for stations connecting with WPA3. That's important to use if you want to make sure your system is robust and not susceptible to someone forging Wi-Fi management frames to try to control your system. And by control, I mean like cause it to disconnect from a network when it shouldn't. So those are a couple specific examples of benefits that can come from WPA3. And in terms of the TI devices that are supporting it, it is both our WiLink and our SimpleLink product families. Specifically on the SimpleLink side, we're supporting it within our Gen 2 and Gen 3 products, which is our CC3X20, CC3X30, and CC3X35 devices.
Okay, very good. The next question is about FIPS validation. Does TI intend to do FIPS validation for CC3220?
No. So today our FIPS validation is limited to our CC3X35 devices. But the good thing about the way our SimpleLink devices are designed is that our Gen 2 and Gen 3 products are software compatible and hardware compatible for the most part, except for the addition of 5 gig that adds an additional external interface for the 5 gig path. But generally, the devices are compatible. So if you're working with a CC3220 based solution and you need FIPS validation, it should be an easy migration to that CC3235 device.
Okay. Here's a related question as well. Why is FIPS important, and which TI devices support FIPS 140-2?
Sure. Yeah. So like I had mentioned earlier, certain applications and sectors require products be FIPS validated, just to ensure the quality of the security and the cryptographic engines used within the device. So in support of that, you need to make sure subcomponents within the system also are validated to get the overall product FIPS validated. So if you're working in those fields, FIPS is important to look for within the Wi-Fi device, because once you add that to that system, that changes how you have to go and get your product certified. But also, if you're not needing FIPS validation for the product, it's still important because it's necessary for a solid security strategy to have a third party independently review the security modules within a product to make sure it's reliably performing to standards set by the government. Okay, I think we have time for one more. Does TI have a process in place to support customers as security threats emerge, and can you provide examples? Absolutely, yeah. So that ties into the TI PSIRT team, or Product Security Incident Response Team, that I mentioned earlier. So TI established this team to handle reports of potential security vulnerabilities that are found within the industry or found by developers as they're working with TI devices. So you can submit information on that to get engaged with the PSIRT team, and then they can start communicating to investigate that vulnerability and decide on next steps once you've kind of investigated that vulnerability. As a specific example of when this has kind of been used in the past for the Wi-Fi devices, there's the well-known crack vulnerability for Wi-Fi protected access. This is one that came in from a researcher. They got in contact with various suppliers. By having the PSIRT team, we were able to quickly get up to speed on the findings and start to investigate the impact to our products, and then plan for mitigation within our products to prepare our customers for protecting themselves against the crack vulnerability.
All right, very good, Ben, and thank you for that. I'm afraid we've run out of time for today. For those questions we didn't have time for, we'll get back to you via email. And that concludes today's presentation. On behalf of Electronic Design, I'd like to thank Texas Instruments for sponsoring today's event, and of course, all of you for joining. Have a great rest of your day.